says solve 6 sine pi over 4x equals 3 for the smallest solutions. So what we're going to want to do is isolate this whole thing by itself on one side of the equation. So we're going to treat that like as if it was one variable, like 6x equals 3 at the moment. So we're going to treat this whole like the equation that says 6x minus 3 equals 3. I mean, I shouldn't say x, we'll say m. So I just let the whole sine pi over 4x be one variable m, and then we treat it like that. And so what we would do is divide by 6 on both sides. So that's what we're going to do in this first step. These 6's will cancel, and I get sine pi over 4 x is equal to 1 over 2. Then now what we do is we do a u substitution, because this part on the inside of these parentheses, this part is called the argument of the sine function. It is the input of the sine function, and when we solve a trig equation, that has to be just u, or it's a way of simplifying this problem so that it makes it easier to solve it. So sine of one variable u is equal to 1/2. So I could just say off to the side here, let u, this is called the u substitution, equal pi over 4x. Then now it says the sine of some angle u is equal to 1/2. So we have to think about the unit circle, because the y coordinates, every y value on the unit circle corresponds to the sine of all angles, and the sine of angles, and so we can look at also we can graph the line of y equals 1/2, and that's going to come up if this is a unit circle, which means it has a radius of 1, then halfway between, up here would be right at 1/2. So it would, the point on the terminal side that's going to have a y coordinate of 1/2, which will intersect a line that is 1/2 above the origin, a distance of 1/2 above the origin, is going to be correspond to two angles that have a terminal side that goes to those points. This first angle is in quadrant 1, and this second angle is in quadrant 2. Both of them are going to have a y coordinate, because the distance off of the x-axis, as 1/2. See, this one will be 1/2 here, and that one will be 1/2 here. So the question is, at what angle here are you that would produce that side of the triangle to be 1/2? Well, this should be one that you have memorized. You should know 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We should have all of them memorized for sine and for cosine of the angle. So this actually is not as bad as it looks. Sine is the y-coordinate, so as it goes from 0 up to 90 degrees, it's getting larger. The y-coordinate there, which is the height off the ground, is getting larger. So that's why it's going to go from 1, 2, 3, 4, sorry, 0. It's going to go 0, 1, 2, 3, 4, and 5. Sorry, oops. And then cosine, if you focus on just the x-coordinate, so that's this distance of the triangle, that's getting smaller when you go from 0 to 30. So that makes sense that we're going to go 4, 3, 2, 1, 0. Then you put everything over 2. And you take the square root of the top of all of them. And that's all of the angles that you should have memorized. So, and if we now simplify this out, the square root of 0 over 2 is just 0. So the sine of 0 is 0. So simplified, that is 0. Square root of 1 over 2 is just the square root of 1 is 1. So it's going to simplify to 1 over 2, 1/2. Which is actually the answer we were looking for. Sine of 30 degrees will be 1/2. So one of the solutions for u is 30 degrees. Now, because they did not really specify for us they didn't really specify if they want their answer to be in degrees or radians. So I'm just going to assume this answer is in radians. Also, because of the pi over 4, pi is usually used when we have radians. So I'm going to rewrite 30 degrees as, and we can rewrite all of these in radians rather than in. So 0 degrees is 0 radians, but then 30 degrees is pi over 6. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees, and pi over 2 is 90 degrees. So that would be pi over 6 is one of our answers here. Hold on. It's the answer to u. So this angle and actually all. Now wait, that angle and this is the angle in the first quadrant, pi over 6. But then there's also one in the second quadrant that would also produce a height of 1/2. So this is the first quadrant answer. This is the second quadrant answer. So this one is actually pi over 6. So this 180 all the way across would have been pi. But we know that it has the same reference angle. That's why it has the same sine value. over here. So this must be a pi over 6 distance between the x-axis here, angle between the x-axis here and the this terminal side of this angle. However, we need to measure that from as in standard position. So it's going to be 6 pi over 6 minus a pi over 6 to find out what this angle is. You could rewrite pi as 7 pi over 7 or 8 pi over 8 or whatever. So I just automatically made it with a denominator of 6 by doing 6 pi over 6, and subtracting 1 pi over 6 is 5 pi over 6. So that's the second angle when u is equal to 5 pi over 6. But we're not done with this problem. And the reason why we're not done with this problem yet is because also all coterminal angles would be a solution to that as well. And they aren't just asking for the 2 smallest solutions, they're asking for the 4 smallest solutions. So I'm thinking that we will need these other solutions as well. So I'm going to rewrite this. U is equal to pi over 6, but then it's plus 1 full revolution, so is 2 pi times r. I'm sorry, 2 times k. K is like the number, is any integer number. Okay, then the second solution over here is 5 pi over 6 plus 2 pi k. Now we need to, now that we've fully solved this problem for all solutions, now we need to actually solve it for x and not for u. But x was equal to pi over 4, x is equal to pi over 6 plus 2 pi k. So now we're plugging back in pi over 4x, where we saw u in the above equations. And to solve for x, we need to you can multiply by the reciprocal of pi over 4 on both sides. So and you've got to remember to multiply everything on this right-hand side because there are 2 terms, so we have to distribute that out to both terms on this right-hand side of the equation. So we're multiplying by 4 over pi. And I put in parentheses pi over 6 plus 2 pi k. And then we're going to distribute that out to both the terms there. And so the first one will be 4 over pi times pi over 6 plus 4 over pi times 2 pi k. And this other side of the equation is going to cancel. These will cancel. And you'll get x. So x will equal, these pi's are going to cancel. I'll just get, and you can reduce this, divide by 2 on both sides, and you get 2 over 3. So this will be 2/3. Plus, then the pi's are going to cancel here, and this is in the numerator, by the way. That's like in the numerator, the 2 pi k. Then we're going to multiply the 2 times the 4 is 8k. So I'm going to solve the other equation similarly, multiplying by 4 over pi. I multiply out this side is going to cancel, and x equals 4 over pi times 5 pi over 6 plus 4 over pi times 2 pi k. These pi's are going to cancel. These pi's are going to cancel. Again, divide by 2, divide by 3, 2 here, divide by 2, and so 4 divided by 2 is 2, 6 divided by 2 is 3. And now we can multiply across on top, and you get 10 over 3 plus, you multiply across, this is like over 1, so that's 2 times 4, which is 8k again. So those are our two solutions. Now to find the 4 smallest, the first one is going to correspond to k being 0. That's plus no revolutions. So our first answer is 2/3. Our second answer will be 10 over 3. So let me back up and do this more clearly. So the next step is to actually let k equals 0. And we plug 0 in to the equation above. So then that would give us, 8 times 0, which would be 0. So that's why we're going to get 10/3. The same thing over here. It's going to be 2/3 plus 8 times 0. So it's just 2/3. So those are our first solutions. Next, we're going to let k equal 1 for both equations. And then I'm going to get 2/3 plus 8, which is 8 2/3. Which is probably going to be better written, if we try to turn it into a decimal, it's not going to be an exact answer, so it needs to be written as a fraction. So to turn 8 into a fraction with a denominator of 3, then I'll write it over here, 8 over 1 with a denominator of 3 means I would have to multiply the denominator, this 1, by 3. Whatever I multiply the denominator, I have to do in the numerator, so that means that 24 over 3 is the same as 8 over 1, so I'm going to replace the 8 here with 24 over 3, and that reveals to us that this answer is written in fraction form. It's 26 over 3. Next, now I plug into the second equation, 10 over 3, 8 times, where k equals 1, then it'll be 8 times 1, and then it'll be 10/3 plus 8. And again, I'm going to rewrite 8 as 24 over 3. So this answer is going to simplify to be 34 over 3. And they did ask here for the 4 smallest solutions. And so if you notice that any other solution that I get is going to be, I believe it's going to be larger than these 4. Sometimes it may be the case that all 4 solutions might, we just have to make sure that there's no other smaller solutions out there than the ones that we have already come up with. But if we if we let k be 2 here, then we're going to be adding 2 8s, and of course those will be larger than the ones we've already got here. So I believe these are our smallest. So here's our answers: 2/3, 10/3, 26/3, and 34/3. And that is the end of this problem. I hope this video was valuable. Thank you.